Okay, so let's continue with our next video in our coding exercise series. So in this video, we will solve the question sequence equation, which is on the HackerRank, and it is the easy category question. All right, it's very easy. Let's read the question. So given a sequence of n integers, so we have n integer is given. So as an example, so let's suppose n is 5. So it means we have a given a sequence of n integers. So if n is 5, it means we have 5 numbers are given. If n is 10, we have 10 numbers are given. Okay. And the numbers are like p of 1, p of 2 to p of n. So basically p could be an array. Right. So p is an array and all the numbers will be in that. So if n is equal to 5, so all the 5 numbers will be stored into that array. So whatever the number is like, so we create a list of 5 length and we will store the elements here. Okay, where each element is distinct. So each element is distinct, so you can't repeat like one or two times, so all the element will be distinct. Okay, and it should satisfy this condition. The condition is p of x. P of x means like whatever the element, like this p, like first index, second index, third index, fourth index, fifth index, or the you can say zero index. All right, so all the element should lie between 1 to n. 1 to n means if n is equal to 5, so it means all the elements should lie between 1 to n. So if n is equal to 5, you cannot store 6 inside that. Also, you can't store 0 or -1 inside that. So if n is equal to 5, all the elements, so there should be 5 elements, so that could be 1 to 5. If there is 6, then there will be 6 elements, and the value of 6 element will be lie between 1 to 6. It can be in any order, so maybe like 5 is here, 1 is here, 3 is here, 4 is here. It can be in any order, right? Okay. For each x, where x is between 1 to n, so for each x, like where n is equal to 1 to n, so this is the array. N is equal to 5. This is satisfying this condition, right? In the Python index, in the Python, we start with the zero index based system. So 5 is on the index 0, 2 is on the index 1, 1 is on the index 2, 3 is on the index 3, 4 is on the index 4. But here they mention for each x, where 1 of less than x is equal to n, all right, that is x increment from 1 to n. So they said like, okay, we have like 5 elements. For all the 5 elements starting from 1, so we have to check for all the elements starting from 1, 1, 2, 3, 4, 5. All right, so you can delete this for the time being. So we have to check for all the elements starting from 4x is equal to 1, 4x is equal to 2, 4x is equal to 3, 4x is equal to 4, 4x is equal to 5. All right, so we have to check for all the elements. We need to find an integer. Okay, so it means they said for all the 5 elements, we need to find an integer y. Okay, and how to calculate the y? So we have this formula is given how to calculate the y, and keep a history of the value y in a return array. So let's suppose for x is equal to 1, using this formula, you found y. So once you found the y, you store into one array. Then for x is equal to 2, you found some value using some formula, then you store in that array. Then for x is equal to 3, then you are storing into that array. Okay, then what it, this formula is. So let's see using the example. So we have array 5, 2, 1, 3, 4. 5, 2, 1, 3, 4. So we have to start from 1 because they said for each x, and x is increment from 1 to 1. All right. So we have to start from 1. So if x is equal to 1, all right. So p of 1, sorry, you can ignore this like a formula for the time. It's little confusing. But here what we need to do is for x is equal to 1, we need to find in the array P where the 1 resides. So for x is equal to 1, we need to find in the array P where the 1 resides. So 1 is on the index 2. All right. So 1 is on the index 2. So you can say P of 1 is equal to 3 because they are taking a 1 based index rather than the 0 based index. But in the Python, we have the index 2, but like we can mention here 2 plus 1 3. Okay, so 2 plus 1 3 because of the 1 based indexing system. Okay, so that is done. Now whatever the element we have found, one second. Now whatever the element we have found, so we have found three. So we found, okay, one is at, one second. So we have found uh, for x is equal to 1, right? So we check for x is equal to 1. We found, okay, where is 1? We found 1 is at here. According to Python, it is at index 2, but according to solution, it should be at index 3. All right, because they are taking like a 1 based indexing. Now we will take this 3, right? We will check, okay, where this 3 exists. So where this 3 exists. So this 3 exists at index 3. So index 3 means 3 plus 1, 4. So it means for x is equal to 1, we found the y value. And what is y value? 4. And we are going to store into the resultant array. Now, because we need to check for all x, like 1 to n. Now x is equal to 1 done. And how many element? 5. So we have to check for all the element like 1, 2, 3, 4, 5. So let's check for x is equal to 2. For x is equal to 2, we need to find where is 2 in this array. So 2 is at index 1. All right, so 2 is index as at index 1. But if we consider 1 based indexing, so it is at 1 plus 1, 2. So now we have the 2. Now where this 2 lies? So again, because the element is same, so it's still at the same location 2. So now our output array is 4 comma 2, because 4 is already there. We are going to append 2. Now x is equal to 3, because we have to check for all the 5 elements. Now x is equal to 3. Where is 3 in this array? So 3 is at index 3. It means at index 4. All right. Now we have to check where is 4. So 4 is at index 4, which means at index 5. All right. So we are going to store 4 to 5. All right. So if you see 4 to 5 is our output array. So this is a very straightforward question, not very much complicated. So what we need to do is we need a one result array, because they said you need to store an output in some array, right? So result array. Now they said, if you read the question, they have mentioned for each x at x start from 1 to n. So they said for each x. So it means we need to run a loop for I in the range of 1 to n. And what is n? Length of p. Length of p. But if you just do length of p, it will run till length of p minus 1. But we need to run till p, till the length of p. So we have to do l plus 1. Okay. Now for I in range of 1 of length of. So what we need to do for x is equal to 1, what we need to find, where is where is 1 reside in this array. So first part is that where is 1 reside in this array. So we have to find index first. Okay, we need to find where is 1, because in the I it will be, in this I we have the 1. So we need to find where is 1. So how you are going to find? So we have the index function of the array, of the list. So we can do p dot index. So within the p array, what we need to find, we need to basically we need to find 1. So it is going to give us 2, but because of the 1 based indexing we have to add 1. Okay. Now, so whatever the output, so our output is 3, so it is going to store into the index of 1. We need to find where is that particular value which we just get in the p array. So as an example, where is 3 in the p array? So it is on the index 3, so output will be 4. So 3 plus 1, 4. Now we need to do result dot append index 2, right? And then return the result array. All right. So for 1, we did 2 operation, because first we need to find, okay, where is 1 in that array. We got the output. Whatever the output we will get, we will find, okay, where is now that output in that array. We are going to find some value, and that value is going to store into the output array. So basically 2 operation, and whatever the value that is the index 2 will become, we are going to store. And we are now for x2, x3, x4, x5. So let's try to run code. So sample test case has been passed. Let's try to submit the code to test all the test scenario. So all the test case has been passed. But if you observe, like all the test cases has been passed because our constraint is just 50. So maximum we have the 50 elements in the array, right? So that's why like it is not giving you like time limit exceed error, because even though you are using the index operation, so index operation is going to iterate, because first you have to find the index of 1, so it is going to iterate, then you have to, then again it is going to iterate, right? So we have like just 50 elements, that's why like it is not giving the timeout array. But if we have the so many elements, like millions and billions of elements, then definitely it is going to give us the timeout array. So what is the another approach? So because we need the index, so why can't we just store the index in a dictionary? All right, so we can create a dictionary. We are going to store the index. So as an example, what we can do is we can create a dictionary. We will store, okay, 5 is at index 1, 2 is index 2, 1 is at index 3, 3 is at index 4, and 4 is at index 5, considering one base indexing. Now once we have this dictionary, we don't need to use this index operation. We can just do the lookup on this dictionary, which will make our life more easier, though we are going to use some extra space. But that complexity will be reduced, time complexity will be reduced, but we are going to use some like space complexity in this case. But in this case we are not using extra space, but time complexity is more. So it depends like which what trade-off you are going to do. So let's try to do the another operation. So what we have to do, we need one result array, we need a dictionary map, or you can say the index map. So for index map, 1 second, there is some noise in the background. Yeah, sorry. So what we have to do is we have to store a dictionary array, right? So what we will do, uh, so what we will do, so we will iterate for index comma value in enumerate of p. We are going to, and we are going to store, so value and index plus 1. So we are going to create a dictionary. So we created a dictionary. Now we need everything same. We need to run a loop for I in range of 1 of length of p plus 1. And to find the index of 1, we are not going to use the p of index. We are going to use the index dictionary. We are going to do, okay, uh, index dictionary. So index of map, okay, where it is. Now again, we are going to use the index dictionary. So instead of this operation, we are going to use the index dictionary, and we are going to remove the plus 1 because we already storing the indexing using plus 1. And that's it. So let's try to run it. Okay, something is wrong. Dictionary object is not callable. Okay, so here we have to use this bracket rather than that bracket. So sample test case has been passed. Let's try to submit to test all the test cases. So all the test cases has been run. So this is like one more approach, and this is like given more priority because the time complexity is less, right? But anyhow, like in this question, because it's the easy category question and the constraint is less, so you can do any method, whether using the index based or whether using the dictionary. So that's it. That's the end of the video, and thank you.